Okay, continuing now with question 21, we're going to do the next batch of 10 questions on this practice final for 2019 practice. This says to use the graph of f of x and g of x below to solve the inequality. Now, the random variable on this one, the symbol could be the less than symbol, the greater than symbol, or the less than or equal symbol, or the greater than or equal symbol. So first of all, the two graphs are equal when they have an intersection point. So these two graphs are equal here, and that happens when x is equal to 1, 2. Okay. All right, now to see this further, because I want to go through the different cases, let's color the graph of x of f blue, and let's do the graph of g in pink. Okay, so this one is f of x. Okay, so all right, so that's my function f, and then g is going to be this one. Okay. Now, let's answer the question here. When is f of x less than g of x? Well, this happens when the graph of f is below the graph of g. So this happens when the blue graph is below the pink graph, and strictly below. So we do not include this point because that happens at equality. Now, these graphs keep going in the direction that you see forever. So when is the blue graph below the red graph? Well, it's below the pink graph here when my x values are coming in from negative infinity up to, but not including 2. Because at x equals 2, it's equal, and this symbol is strictly less than. So the answer is going to be the blue is below the pink when your x values are coming in from negative infinity up to, but not including x equals 2, because at x equals 2, they're the same, so it's not below. So that's what I look for here, and that's the one that we want. Okay. Now, if the question had been, when is f of x less than or equal to g of x? Well, that happens when f is either on or below. So we include that intersection point. And so then our interval would have included 2. Now, what if the question had been, when is f of x strictly greater than g of x? Then that happens when the graph of f is above g. And so wherever the blue one is above the pink one, and we can see the blue one will be above the pink one from here on out. Now, at their intersection point, they're the same, so blue is not above. So the blue, or f, will be above when x is bigger than 2. And so the answer is when x is bigger than 2, but in interval form, that's going to be that. So if it was with the arrow pointed that way, we would have looked for that. And then finally, if the question had been, when does that happen? Well, that happens whenever f is on or above the graph of g. So we would include the intersection point there. So they're the same, they're equal when x is 2, and so and f is above. So f is on g, at x equals 2, and f is above g once x is bigger than 2. And so the answer for that one would have been that. So since you're taking an online final, it'll be from a test bank, randomly generated, and so this symbol might change. And so you need to know how to do it for all symbols. All right, here we're just going to find the product, and so you're just going to have to FOIL. Okay, so that's not too bad. So if I'm going to do this, I'm going to have a 2x times 6x, which is going to give me 12x squared, plus 2x times 4, which is 8x. Then I have negative 5 times 6x, which is minus 30x, and negative 5 times 4, which is minus 20. And 8 minus 30 is negative 22, so I'm going to get a minus 22x there, and then minus 20. So that's the answer that I'm looking for. So 12x squared minus 22x minus 20. Okay, that's the one I've got. So C. All right, now we're told to factor out the greatest common factor. Okay, so let's see how we do this one. Let me write it down a little bit bigger in the black ink because I don't think this shows up so great in the video. Okay, so let's start in alphabetical order. Let's look at M. What is the most that these three have in common as far as M is concerned? And this only has one M. This has two M's. This has three M's. So the most they have in common is one M. So if I remove one of the M's from each of these, what are we going to be left with inside? Well, if I remove one of these, I'm going to have two M's. If I remove one of these M's, I'll have one left. If I remove these M's, well, they cancel out completely, and I'll just have that left. Okay, now let's keep going. From what's left inside here, we've already factored out the M's. What about the N's? This has two N's, this has three N's, this has two N's. So the most that they have in common is two N's. So I'm going to bring that out the front. And what are we left with in here? Well, if I remove two N's, or factor out N squared from each of these. Okay, so the N squareds here cancel, and I'm just going to be left with M squared times P. Here I have three N's, and I'm going to remove two of them, so I only have one left. And here the N squares cancel, and I'm left with P squared. And now, what about the P's? What's the most that they have in common? All of these have in common at most one P, so I'm going to bring it out the front. And what am I left over with? Well, if I remove one P from each of these, they cancel there. If I remove one P from that, I have M, N, and P. And then if I remove one P from P squared, I just have P. Okay, now what is it asking me for? It's saying factor out the greatest. Okay, if it had asked me what is the greatest common factor, then the answer would be what's out the front there. But it wants just what I get when I factor. Okay, so let me fold this down so we can choose. So this was my final answer. All right, so that was my final answer, and I'm looking for M N squared P out the front. So B and D have the correct thing out the front. And then I want M squared plus MNP plus, okay, so that doesn't match. So my answer here is going to be D. Okay, that matches up D. All right, now it says to factor this trinomial. All semester, I've been mentioning several times across different videos, if you have something of the form x squared minus k, where k is some real number, positive real number, then this will always factor as x minus the square root of k times x plus the square root of k. And it will work if k is not nice, because that one's not particularly nice, because 7 is not a perfect square, but it still works. And if k is nice, as in if it's a perfect square, and here they want you to find x squared minus 4, then you're going to have, from the formula here, x minus the square root of 4 times x plus the square root of 4. And so square root of 4 is nice, so I'm going to get x minus 2 times x plus 2. Now, the order doesn't matter. I could have had x plus 2 times x minus 2. So let's see what we have. X minus 2 times x plus 2. Okay, just what I got here. So the answer here is B. All right, now they want you to factor this trinomial. Okay, always look to see if you can factor out something in common. They don't have anything in common. So what are we going to do for this thing? Okay, now we start with, they don't have anything in common, so I can't factor anything else. So start with 6. What pairings can you get to get 6? And you have the advantage here of the order, you don't have to do varying orders. So I could have 1 times 6, I could have 2 times 3. Well, see, this one has a 1 and a 6, and this has the 2 and 3. So let me just try 2 and 3. And if that pairing doesn't work, then I'll try the other. Now, what about negative 10? I could have negative 2 and positive 5. I could also have positive 2 and negative 5. I could have 5 and negative 2. And I could have negative 5 and positive 2. Then I could have 1 and 10. I could have 1 and negative 10, or negative 10 and positive 1, or negative 1 and positive 10, and 10 and negative 1. Good Lord. Okay, now, hopefully I don't have to try all of these out. But I can see if I didn't pick the right one here, and it should be 1 and 6, then I will have a problem. Now, how do I check these? Well, I pick these pair, and I'll take the outer product and add it to the inner product. And I want to get the number negative 11 when I do. Okay, so the outer product here is 10. The inner product is negative 6. And 10 plus negative 6 is 4. And that does not equal negative 11. So that's not the right pairing. All right, now I'm going to do the same test with this. So the outer product is negative 10. The inner product is 6. And negative 10 plus 6 is negative 4, which is not negative 11. So here I'm going to have negative 4 plus 15. Negative 4 plus 15 is positive 11. That is not negative 11, so that's not the right pairing. All right, what about this one? This is going to give me positive 4 plus negative 15. 4 minus 15 is negative 11. I have found the pairing that will work. So once you found the pairing that works, how do you do it? So the pairing that works is 2 and 3 and negative 5 and 2. Okay, so once you found the pairing that works, here's how it will be done. You'll have 2 times x here and 3 times x there, then minus 5 and plus 2. So this is going to equal 2x minus 5 times 3x plus 2. And so that's the one. And now the order doesn't matter. They could have put them in a different order, but let's just have a look. Here we go. 2x minus 5 times 3x plus 2. So the answer is A for that one. All right, now simplify the square root of 96. All right, now let me tell you, if you do this, put the square root of 96 in your calculator and you get that and you circle D, you have thrown away your points. because that is not the square root of 96. Your calculator can only take things to 9 decimal places. The square root of 96 is irrational, and what you see there is an approximation to 9 decimal places. That is not the actual square root of 96, and that is a wrong answer. All right, so you might well say, well, what do we do? 96 is not a perfect square, as we know. Then you need to rewrite 96 as a product, where something in the product is a perfect square. Well, 96 is even, so I can divide it by 2. But then I would have 2 times 48. And 2 is not a perfect square, and 48 is not a perfect square. So let's divide 96 by 4. And that could possibly be the way to go. I can rewrite 96 as 4 times 24. Okay. So I can rewrite the square root of 96 as the square root of 4 times the square root of 24. And the square root of 4 is 2. Now, you're not done yet. Can you rewrite 24 in that same way? Because 24 is also not a perfect square. So again, we don't want to get excited and choose that one. Not yet, because we just got to make sure we're not done yet. Is it possible for you to rewrite 24 using this same trick? And 24 is 8 times 3, but 8 is not a perfect square and 3 is not a perfect square. 24 is also 4 times 6. So I can rewrite 24 as the square root of 24 as the square root of 4 times the square root of 6. Now, this will be 2, and then the square root of 4 is 2. And those multiplied together is going to give me that. So the square root of 96, and I can't do anything with 6 now. I cannot rewrite that as a product where something in the product is a perfect square. So in simplified form, the square root of 96 is 4 times the square root of 6. So the correct answer here is selection C. Okay. Now here with number 27, they want you to simplify this. Okay, so let me write that down. They want you to simplify that. Okay. Well, the first thing we notice is there's a negative sign inside there. So you can always get the negative sign out and it turns into an I. Okay. Now, what you should not be doing here is saying, oh, 4 divided by 2 is 2 and 16 divided by 2 is 8. You can't do that because 16 is inside this square root. So don't do anything like that until you're done. And we're not done yet. So in the top, I'm going to have 4 minus, well, the square root of 16 is 4. And now you can split this up. There's only one thing in the denominator, so I can split it up like that. And so 4 divided by 2 is 2. 4 divided by 2 is 2. And so that's what we're going to get there. So 2 minus 2i is how that one will simplify. Okay, now compute I to the 5th. Well, we know that I squared is equal to -1. So let's rewrite I to the 5th. The first way I'm going to rewrite I to the 5th is I'm going to rewrite it as 4 plus 1. So I'm going to rewrite 5 as 4 plus 1. And then I'll have I to the 4 times I to the first power, which is just I. And now, because I know this, I'm going to rewrite 4 as 2 times 2. And then using the exponent rules, that's the same thing as I squared all squared. So the exponent rules say you multiply those. So if you were going backwards, you could see how this works. Now, we're going to use the fact that I squared is -1. And if you have a negative number raised to an even power, the negative symbol disappears. So this is going to give me +1 times I, and 1 times I is just I. So I to the 5th power is I. Okay. Now, you might be asked to do I to the 6th, or I to the 7th, or I to the 8th. And again, in your web work and lab instructions, there are several examples of these different types here. All right, now number 29, we are going to FOIL that, but we have to remember that I squared is equal to 1. So let me write that here. So we have to remember that I squared is equal to -1. Okay, so if I'm going to FOIL this, I'm going to have 5 times 4 plus 5 times -2i, which will be -10i. And then I'm going to have I times 4, which we write as 4i. And then I'm going to have I times -2i, which is going to give me -2 times I squared. So here, -10i plus 4i is -6i. Okay. And here I'm going to have -2 times I squared, which is -1. So I'm going to have 20 minus 6i, and then plus 2. And so 20 plus 2 is 22. And my answer is going to be 22 minus 6i. And we have 22 minus 6i for number 29. Okay, so that concludes the latest batch of 10 questions.